In today's video, we're going to look at another way to solve out quadratics. This one is solving quadratics by graphing. And this is actually going to connect what we talked about our very first day with some of our graph properties and our solving by graphing, that we looked at in the last lesson. So let's actually look at both of these methods side by side, trying to solve the same problem. So let's solve out the expression or the equation x squared plus 6x equals, or plus 8 equals 0. And so on this, we are looking at, shuffling some papers. Let's start by factoring. So we have our x squared plus 6x plus 8 equals 0. Factoring this out, we can start with our x's in the front of both factors. So we really only need what kind of factors of 8 would then add together to make 6. So we can use a 2 and a 4, both positive, and then set each factor equal to 0 and solve them out. So x plus 2 equals 0, aka x equals -2. X plus 4 equals 0, or x equals -4. And so our two solutions come out to be -2 and -4. So let's connect this to what the graph of this function would look like. So let's go over to Desmos and graph this out. So again, all we need to do is type it in exactly the way it looks. Actually, we don't even need to do y equals on this, but it works the best when we do that. So I'm going to do y equals, and then whatever expression we had set equal to 0. So we have an x squared, and then we had a plus 6x plus 8. And so looking at our graph, we have two x-intercepts, one at -4, 0, and the other at -2, 0, which is exactly what our solutions were. And so quickest way to solve most quadratics, graph it and look for the x-intercepts. So let's go back and write those down. So again, our x-intercepts happened at -2 and -4. And we had actually a y-intercept at 8, 1, 2, 3, 4, 5, 6, 7, just above the graph. And actually, let me go back to Desmos. We had our vertex at -3, -1. Always a good idea to note that down. So -3, -1. So I went way far off base. -4 is here. And so here is our graph. So again, easiest way, kind of almost like starting by solving by factoring. Make sure you have everything set equal to 0 and then just solve for x. So let's check out a few more. Actually, before we do that, let's kind of write this down. So solutions of a quadratic equation written in the form ax squared plus bx plus c equals 0, or in our factored form, are always going to be the solutions, the zeros, or the roots, or we could even add in as well x-intercepts of the graph. Same thing we wrote in our previous examples. And so there's three scenarios that might happen. So think about the different ways that you could draw a parabola. So we could have a situation where we only have one real root, and that's going to be a scenario where our parabola just kind of hits the x-axis and bounces right back. And the reason that is called a double root is because when we solve it out, we're still going to have two separate roots, two different answers that come out, but they're going to be the same number. We could also have a graph kind of looking like this. This would also be a double root solution. Two real solutions means the graph is going to hit the x-axis in two places. And again, doesn't matter if it's facing up or facing down. It's all about finding those two x-intercepts that are on each one. So two different versions of what that could look like. No real solution. Well, could we draw a parabola that doesn't hit the x-axis? Well, sure. If we had something like shifted all the way up, it would eventually hit the y-axis, but that's not where we get our solutions from. We're always looking for the x-intercepts on there. So keep in mind an equation with a double root or that only has one solution, it's actually going to have two answers the same. So you might have factors of like x plus 2 and x plus 2 coming out of your factoring. Anything with no real solution, well, that means there's no x-intercepts. That means there's no roots. There's no factors. It would be unfactorable. And actually, next class, we're going to look at, well, how could we solve it if we can't factor it, but maybe it still hits the x-axis. So we'll look at that possibility next time. So let's keep going. Okay, so examples, we're going to solve each of the quadratics by graphing. So again, the biggest thing is we're going to want to go through and actually graph these out. But before I do that, again, make sure everything is set equal to 0. So we're going to do x squared, move everything over. So subtract your 6x, add your 10, and set that equal to 0. And then we pop over to Desmos and we graph it out. Okay, so graphing this out, again, open up my keyboard. I want to delete. So we are looking at, again, x squared minus a 6x plus a 10. Oops. Does this have a solution? Bummer, no intersection point, so no solution on this one. Darn it. He's sitting up here. No solution. Okay, number 3. So again, we have to do a little bit more rearranging on this one. We always want to have our x squared first, but he has a negative out front, which is fine. I can move the negative with it. Our 8x assumed positive, and I need to subtract a 16 from both sides. Oops. So again, let's pop over and graph it. So one of the neat things, if you don't want to lose track of the graphs that you've done, you'll notice there's that red dot with a squiggle through it. If you click on that, it'll actually turn your graph off for you without losing your equation. So if you ever want to try graphing stuff out, you can absolutely do that. Keep in mind, if you're looking at an assessment, those graphs do not hold over question to question. And you should never have anything else open other than your assessment. Okay, and then we subtracted a 16 and the whole thing equals 0. So let's see here. Well, I can only see one number, so I'm thinking I need to look at more on this graph. We had, let's kind of zoom out. I'm getting a vertical line. So that means I probably typed something in incorrectly. Let's see here, let's double check. And delete. I didn't type it in as y equals, didn't I? And when that happens, when you get something that doesn't look like a parabola, that can be your idea, double check how you typed it in. There we go, that makes a little bit more sense. So we have an upside down parabola, but it's only hitting it one place. It's only hitting it 4, 0. So let's sketch that out. And again, you'll notice I didn't give you all the grid lines on here, just enough that we can sketch out the points. And again, that was hitting at 4, 0. So that's our solution. So x equals 4. This is one of those scenarios that has a double root. So if I actually factor this out, I'd have two factors that both solve out to give me the answer 4. Alrighty, so number 4, again, all we have to do is move the 4. So minus 4 equals 0. And then we go through and we graph it out. So I can turn off my previous graph and let's type in the new one. So y equals x squared minus 3x, whoops. If that ever happens, just use your arrow keys and kind of move over. You can absolutely use your arrows to kind of move to a new place in the equation. And then we subtracted a 4. So this one, we have intersections happening at -1 and 4. So let's sketch that out. So -1 and 4. -1, and 4. So our solutions for x, -1 and 4. So just like we did with solving by factoring, if we start with a graph and we know the x-intercepts, we know the zeros, we can actually start writing equations just from that. If we happen to also know extra information like how far it's being stretched or what our vertex is, then we can start playing around with which format we start writing. So keep in mind, if you have a factorable expression, then all you need to do to write the equation is you're plugging in your x minus whatever your answer was. So do the same thing with a graph. So in number 5, we have x-intercepts at -1 and +3. So a quadratic function that would look very similar to this, maybe not exactly, would be x plus 1, because it's always minus that value that you have inside your parentheses, and x minus 3. In this case, I'm noticing I've got a really nice vertex, and I only have to go up 1 over 1, so I also know that I don't have to stretch this out at all. Now, if it's worded as write a quadratic equation, notice it didn't say write the quadratic equation. So if you're just told, here are my zeros, you can still write that factored form out. It's not just going to, or it's not going to be as specific if you don't have that extra info. Number 6, if all I'm focusing on is the -2 and the 0 as my factors, well, if 0 is a factor, x minus 0, do we really need to write that? No, we can just write x. And then we have the -2, so x minus a -2. And again, I do know that this one is flipped upside down, so I could also have written -x times x plus 2. Both of these are in factored form, and both of them have the x-intercepts of -2 and 0. But if the question's worded write a quadratic equation that will intersect the given points, it would still work for a solution. Okay, number 7. I know a vertex. Here's the kicker. That's it. There are no other x-intercepts. So that means how many times did this solution show up if we were solving by factoring? Well, we'd have to show up twice. So one function that we could write would be x minus 2 times x minus 2. Noticing anything else more specific about the graph that we could use, though? How far over and how far up do we have to go to get to the next point? So since I have to go up 2, I could get more specific and actually write out that this is 2 times x minus 2 times x minus 2. And technically, do you know another way that we could write this function that would also still be correct? What if I wrote it in vertex or transformation form? So that would be f of x equals 2 times x minus 2 squared. All three of those still all go through the same exact x-intercepts or zeros. Alrighty, so 8, 9, and 10, they don't give us the specifics. So this is definitely where an equation comes in, because all we have to go on is the zeros that they gave us, unless they gave us an extra piece of info, which I actually gave you in 9 and 10. In number 8, though, it's just the zeros. So all I can write is x minus my -2 and x minus my 4. That's all the info I have. If I'm going to write an equation for number 9, though, I can get more specific. It says first we have a double root at 3. So that means I could do x minus 3 or even x minus 3 squared. I'm going to write it out twice. But then it has a vertical dilation of 4, which means what extra value are they giving us to write out? They're giving us that a value in front. And again, there are multiple versions that we could write of this. I could very easily write it in kind of vertex or transformational form, or I could go wild and crazy and multiply it out. But the directions just said write an equation, so it doesn't really matter what format I leave it in. Number 10 is giving us even more specific. So zeros at the origin and at 3. So that's where my x-intercepts are. So I can start with x minus 0 which is just x, and 3, so x minus 3. But then they give us that extra piece of info. So with a reflection over the x-axis, what did we have to change in our equation to make it reflect vertically? That needs to be a negative a value, and in other words, a -1 or negative x. And there's my function. And again, not the only functions that have these properties, but I'm limited by how much information I'm given. Now, if I'm given a graph, I can get really specific. But if I'm not given that graph, as long as the equation has those properties, I'm good to go. As always, let me know if you have any questions, and I will see you later.